Welcome to your personalized deep dive into ISRO,
Oh,
the Indian Space Research Organization.
wow.
You've sent us a treasure trove of articles, research snippets, and even some personal notes.
Okay.
So clearly you're ready to go beyond the basics.
Yeah, it's always exciting to see a listener who's already done some digging.
Yeah.
It gives us a great launch pad for our exploration.
And what an exploration it'll be.
Right.
We're going to uncover how ISRO transformed from humble beginnings into a global space powerhouse.
Yeah.
A story that's intertwined with India's journey as a nation. And I see from your notes that you're particularly interested in their self-reliance and how they managed to achieve so much with limited resources.
That's a key insight that often gets missed.
Yeah.
ISRO's story isn't just about technological prowess.
Really?
It's about overcoming challenges and forging a path of independent innovation.
Okay, let's unpack this.
Sure.
Your research mentions some early pioneers like S.K. Mitra and C.V. Raman,
Yeah.
who were conducting groundbreaking work in the 1920s. What was the significance of their contributions in the context of India's space aspirations?
Well, think of them as laying the scientific foundation.
Yeah.
They were exploring fundamental concepts,
Okay.
from the ionosphere to the nature of light, which would later inform India's space program. It's like building a house.
Okay.
You need a strong foundation before you can even think about the roof.
And speaking of foundations,
Yeah.
your notes highlight Vikram Sarabhai and Homi Bhabha as pivotal figures.
Right.
You even have a handwritten note about Sarabhai's physical research laboratory in Ahmedabad.
Their impact can't be overstated.
Yeah.
They were visionaries who understood that scientific advancement was crucial for a newly independent India. Sarabhai in particular saw space exploration as a tool for national development, not just a scientific pursuit.
So it wasn't just about reaching for the stars.
No.
It's about leveraging space technology to solve problems here on Earth. And this vision was put to the test in 1957 when Sputnik 1 launched, marking the dawn of the space age. I can imagine that sent shockwaves through the world.
Oh, absolutely.
Suddenly space was no longer a distant dream, but a reality.
Yeah.
And nations were scrambling to catch up.
And India was no exception.
Yeah.
Sarabhai seized the moment and, with the support of Prime Minister Nehru, established INCOSPAR in 1962.
INCOSPAR being the precursor to ISRO, right?
Yes.
What were some of their early priorities?
They started with sounding rockets.
Okay.
Those smaller rockets designed for atmospheric research. They were launched from Thumba, which you've highlighted in your notes. It's located right on the equator, which offers unique advantages for studying the upper atmosphere.
So that's why that location was chosen.
Yeah.
And they even developed their own sounding rocket series called Rohini. It's amazing how they focused on building indigenous capabilities right from the start.
That drive for self-reliance was shaped by several factors. Limited resources, geopolitical realities, and a desire to chart their own course in the space race.
Okay.
It's a recurring theme in ISRO's journey.
So we've got this foundation laid.
Right.
But when does INCOSPAR officially transition into ISRO?
That happened in 1969 with Indira Gandhi as prime minister.
Okay.
A dedicated Department of Space was established in 1972, solidifying ISRO's place within the government. This marked a turning point.
Yeah.
A shift from early experimentation to a more structured and ambitious approach.
And that's when things really start taking off, right?
Absolutely.
ISRO sets its sights on launching its own satellite.
Yeah.
Leading to the development of Aryabhata in 1975.
That's right.
I remember from one of your articles that while Aryabhata was indeed India's first satellite, it was launched with the help of the Soviet Union.
That's an important nuance.
Yeah.
It highlights ISRO's pragmatism.
Okay.
They recognize the complexities of launching a satellite.
Right. And sought collaboration.
Yeah.
While simultaneously working towards their own launch capabilities.
It's a smart strategy.
Yeah.
Learn from others while building your own expertise.
Precisely.
And just 5 years later, they achieved that milestone with the successful launch of Rohini aboard the SLV-3, making India the 7th nation to achieve orbit.
Wow.
Now that's a moment of national pride.
It certainly was.
It must have solidified ISRO's place on the world stage.
It certainly did.
And it set the stage for even bolder endeavors.
Yeah.
But ISRO didn't rest on their laurels.
No.
They recognize the need for diverse launch vehicles to meet different mission requirements.
Right.
And this is where the PSLV and GSLV come in, right?
Exactly.
You've got several articles comparing these two workhorses of ISRO's launch fleet.
The PSLV, with its remarkable track record of 50-plus successful launches,
oh, wow,
has become a global favorite for launching smaller satellites into polar orbits. It's reliable, efficient, and cost-effective,
showcasing ISRO's ability to cater to a niche market.
And the GSLV, with its heavier lift capacity, is meant for those larger payloads destined for geostationary orbit.
Yeah.
The kind used for communication and broadcasting satellites.
Right.
You mentioned in your notes that its development was quite challenging.
Yeah.
Especially when it came to mastering cryogenic engine technology.
The GSLV story is a testament to ISRO's perseverance. They faced setbacks, including sanctions that restricted their access to crucial technologies. But this only fueled their determination to develop indigenous capabilities.
Wow.
Ultimately leading to breakthroughs in cryogenic engine development.
It seems like every challenge they encountered only strengthened their resolve.
That's a key takeaway.
Yeah.
It's this unwavering spirit that has propelled ISRO to where it is today. They didn't just launch satellites.
Really?
They've built an entire space ecosystem.
Okay.
From launch vehicles to ground stations, training institutions, and even commercial ventures.
And while they were mastering these technologies, they were also developing their own satellite systems.
Right.
Like INSAT and IRS. You've got pages of research on these programs.
Yeah.
Highlighting their impact on everything from telecommunications to disaster management and resource monitoring.
It's a remarkable feat of parallel development.
Wow.
They didn't just focus on one aspect. They recognized the interconnectedness of the space ecosystem.
So they weren't just launching things into space.
No.
They were creating a system that could benefit life here on Earth.
Exactly.
And that brings us to the heart of ISRO's philosophy.
Yeah.
Space technology as a tool for human betterment. All right, we've laid a solid foundation here.
Right.
Tracing ISRO's journey from its early days to its emergence as a major player in the space arena. But this is just the beginning.
Yeah.
You mentioned in your notes a particular interest in how ISRO is structured.
Right.
And how this organizational model contributes to their success.
Let's dive into that next. It's like peeking behind the curtain to see how the magic happens.
All right.
I love that analogy.
So
let's see how ISRO makes its magic.
Yeah.
Okay.
Let's do it.
What's fascinating about ISRO is that it's not a single giant entity. No. It's more like a well-coordinated network, a constellation of specialized centers spread across India.
So that explains why your research mentions places like Thiruvananthapuram, Ahmedabad, and Sriharikota.
Exactly.
They each have their own unique role to play in the larger ISRO ecosystem.
Exactly. You mentioned the Vikram Sarabhai Space Center in Thiruvananthapuram. That's where ISRO's heavy lifters are born.
Okay.
The SLV, ASLV, PSLV, and GSLV launch vehicles were all developed there.
So it's the heart of ISRO's launch vehicle program.
You could say that, and right alongside it is the Liquid Propulsion Systems Center.
Okay.
Also in Thiruvananthapuram, that's where those powerful liquid engines that propel these rockets come to life.
I noticed in my reading that one of their key engines, the Vicus, is actually based on the French Viking engine. It seems like even with their emphasis on self-reliance, they're not averse to collaboration and learning from others.
It's a strategic approach.
Okay.
They're open to technology transfer.
Right.
But always with the aim of building indigenous capabilities. The Vicus engine is a perfect example. They adapted and improved upon an existing design, eventually mastering the complex technology involved.
Okay, so we've got the birthplace of the rockets.
Yeah.
What about the place where they actually take flight?
That would be the Satish Dhawan Space Center.
Okay.
On Sriharikota Island, it's ISRO's primary launch site, strategically located on the coast for optimal launch trajectories.
And it's also home to India's largest solid propellant plant.
That's right.
As you highlighted in your notes. I'm curious, what's the difference between solid and liquid propellant?
Oh, that's a great question.
And why does ISRO use both?
Solid propellant motors, like those used in some of the early-sounding rockets.
Yeah.
And even in the PSLV's boosters are relatively simple and reliable.
Okay.
Think of it like a giant firecracker.
Yeah.
Once you ignite it, there's no stopping it.
So they're powerful, but less flexible in terms of control.
Exactly. Liquid propellant engines, on the other hand, offer more control over thrust.
Yeah.
And can be throttled up or down.
Okay.
Even shut off and restarted.
Wow.
That makes them ideal for more complex missions.
Right.
Especially when precise maneuvering is required.
So it's about choosing the right tool for the job.
Exactly.
Solid propellants for simpler missions.
Right.
Liquid propellants for those requiring more finesse.
Precisely. And ISRO has expertise in both.
Okay.
Giving them the flexibility to design launch vehicles tailored to specific payload requirements.
Okay, so we've talked about the centers involved in building and launching rockets.
Yeah.
But what about the data those rockets carry into space? The satellites that are at the heart of so many of ISRO's applications.
Excellent point. That's where centers like the Space Applications Center in Ahmedabad come in.
Okay.
They focus on taking the raw data from those satellites and turning it into something useful here on Earth.
So it's not just about getting things into space.
Yeah.
It's about using that vantage point to solve problems and improve lives here on Earth.
Exactly. And that's reflected in the wide range of applications ISRO is involved in.
Yeah.
From geodesy and cartography to telecommunications, meteorology, disaster management, and even agriculture and resource monitoring.
Wow.
You've got a whole stack of articles highlighting these diverse applications.
And they even have specialized institutions.
Yes.
For training the next generation of space scientists and engineers.
Absolutely. You mentioned the Indian Institute of Remote Sensing in Dehradun.
Yeah.
And the Indian Institute of Space Science and Technology in Thiruvananthapuram. These institutions are crucial for nurturing the talent pipeline that keeps ISRO at the forefront of space exploration.
It seems like they've got all the bases covered.
They really do.
Research and development, launch capabilities, applications, and even education and training.
Yes.
But what about the commercial side of things?
Right.
Does ISRO actually sell its services and technologies to other countries?
They do, and quite successfully.
Really?
That's where Antrix Corporation comes in as ISRO's commercial arm. They market and sell ISRO's products and services globally. They've launched hundreds of foreign satellites over the years.
Wow.
Generating revenue and forging international partnerships.
So they're competing in the global space market.
More than competing. They're carving out their own niche.
Right.
They've become a go-to option for launching smaller satellites, offering reliability, cost-effectiveness, and a track record that speaks for itself.
Okay. This is all very impressive.
It is.
But I want to bring it back to Earth, so to speak.
Okay.
What does all of this mean for people on the ground?
Yeah.
How has ISRO's work actually touched lives in India and beyond?
Now that's the truly inspiring part.
Okay.
Let's start with telecommunication. You highlighted in your research the INSAT system.
Yeah.
Which is a cornerstone of India's communication infrastructure.
I understand it's like a giant network of satellites beaming down communication signals across the country.
Think of it as a lifeline.
Okay.
Connecting even the most remote corners of India. It's crucial for broadcasting, telephony.
Right.
Internet connectivity, and even disaster management.
Okay.
Imagine being able to warn a coastal village about an impending cyclone via satellite communication.
Wow, that's life-saving technology.
It is.
It sounds like INSAT is truly connecting India in a way that wouldn't have been possible otherwise.
Absolutely, and it goes beyond just communication.
Okay.
ISRO has pioneered the use of satellite technology for education, using it to broadcast educational programs to remote villages, bridging the gap in access to quality education.
That's amazing. And what about agriculture?
Right.
I've got a whole section in your notes about how ISR is helping farmers.
The IRS satellites play a crucial role here.
Okay.
Their high-resolution imagery provides farmers with valuable data on crop health, soil conditions, and even water availability. This information helps them optimize their practices, leading to better yields and more sustainable farming.
So ISRO is not just reaching for the stars.
Right.
They're helping to put food on people's tables.
It's about using space technology to address real-world challenges.
Yeah.
To empower people and improve their lives.
And speaking of empowerment, you mentioned telemedicine as another key application.
Oh, yes.
How does that work?
Imagine a doctor in a major city being able to diagnose and consult with a patient in a remote village.
Okay.
All thanks to a satellite link.
Wow.
ISRO has developed telemedicine vans equipped with this technology, bringing specialized healthcare to those who would otherwise have limited access.
It's like a virtual doctor's visit, but via satellite.
That's a great way to put it, and it's just one example of how ISRO is bridging the gap in healthcare access.
All of this is incredibly inspiring.
It really is.
It's clear that ISRO is more than just a space agency.
Right.
They're a force for good, leveraging their expertise to solve real-world problems. But let's not forget their forays into the realms beyond Earth's orbit.
Right.
You mentioned a deep interest in their planetary exploration missions.
Yes, from the moon to Mars and beyond.
Okay.
ISRO has been making waves in planetary science, and they've done it in a way that's that's captured the world's attention, proving that ambitious space exploration doesn't always require a massive budget.
All right, let's blast off on this next leg of our deep dive.
Let's do it.
Exploring ISRO's extraordinary planetary missions.
When it comes to exploring our celestial neighbors, ISRO has been remarkably strategic. They've chosen missions that align with their scientific goals, while keeping costs in check.
And they seem to have a particular fascination with the moon, right?
It seems that way.
Your research is packed with information on their Chandrayaan missions. What makes the moon such a compelling target for ISRO?
Well, the moon is like a stepping stone.
Okay.
A celestial laboratory right in our backyard. It offers valuable insights into the early solar system and the processes that shaped Earth and other planets. And from a practical perspective, it's a testing ground for technologies that can be applied to more distant destinations.
So it's scientifically rich and relatively accessible.
Yes.
Making it an ideal target for a space agency like ISRO.
Exactly.
Your notes mention Chandrayaan-1, which launched back in 2008. What were some of its key achievements?
Chandrayaan-1 really put ISRO on the map when it came to planetary exploration. It confirmed the presence of water molecules on the moon, particularly in the polar regions.
That was a groundbreaking discovery, wasn't it?
It was.
I remember reading about it.
Yeah.
But why was finding water on the moon such a big deal?
Well, water is essential for life as we know it.
Right.
Discovering its presence on the moon opens up possibilities for future lunar exploration.
Okay.
Even for potential human settlements.
So it's not just about scientific curiosity.
Yeah.
It has implications for the long-term future of space exploration.
Exactly. And beyond the water discovery.
Yeah.
Chandrayaan-1 provided a wealth of data on the moon's mineral composition topography and even its thin atmosphere.
You even mentioned that the mission team received an award from the American Institute of Aeronautics and Astronautics.
That's right. It highlights the global impact of ISRO's achievements.
Wow.
Chandrayaan-1 wasn't just an Indian mission.
Right.
It was a contribution to our collective understanding of the moon.
Okay, so Chandrayaan-1 laid the foundation for further lunar exploration.
Yeah.
Your research then jumps to Chandrayaan-2, which was launched in 2019. What were the goals of this mission?
Chandrayaan-2 was even more ambitious.
Okay.
It included an orbiter, a lander, and a rover.
Wow.
All designed to study the moon's south polar region.
Right.
A particularly intriguing area because of the potential for water ice deposits in permanently shadowed craters.
I remember there being a lot of anticipation surrounding the landing of the Vikram lander.
Yeah.
And the deployment of the Pragyan rover. What happened?
Unfortunately, the Vikram lander experienced a hard landing.
Oh, no.
And lost communication just moments before touchdown. It was a setback, no doubt.
But the orbiter component of the mission continued to function, right?
Yes, and it's still sending back valuable data today.
Oh, wow.
Studying the moon's surface and atmosphere. And it's important to remember that even in the face of this setback, ISRO learned valuable lessons.
And applied those lessons to their next lunar venture, Chandrayaan-3.
Exactly.
And this one was a resounding success, right?
Absolutely. In August of 2023, Chandrayaan-3 achieved a soft landing near the lunar South Pole, making India only the 4th country in the world to accomplish this feat.
That's an incredible achievement. It must have been a moment of national pride and celebration.
It was.
What are the plans for Chandrayaan-4?
Chandrayaan-4 is already in the works.
Oh, wow.
And it aims to be even bolder.
Okay.
The goal is to land on the moon, collect samples, and bring them back to Earth for further analysis.
So ISRO isn't just content with landing on the moon.
Yeah.
They want to bring a piece of it back home.
And they're also collaborating with Japan on the Lunar Polar Exploration Mission, or LUPEX, to further study the moon's polar regions.
Okay, so the moon is clearly a high priority for ISRO.
It is.
But let's shift gears to another celestial body that has captured humanity's imagination.
Okay.
Mars. You've included several articles about ISRO's Mars orbiter mission, also known as Mangalyaan.
Right.
What was special about this mission?
Mangalyaan was a game changer for ISRO. It marked their first interplanetary mission, a bold leap beyond Earth's orbit.
Wow.
And what made it even more remarkable was that they achieved Mars orbit on their first attempt.
Seriously, that's incredible. Getting to Mars is notoriously difficult.
It is a testament to their engineering prowess and their ability to optimize resources.
Right.
They did it on a budget that was a fraction of what other space agencies have spent on similar missions.
That's really impressive. So what did Mangalyaan discover during its time orbiting Mars?
It sent back stunning images of the Martian surface.
Wow.
Studied its thin atmosphere and even searched for traces of methane, a gas that could potentially indicate the presence of past or present life.
So ISRO is contributing to the global effort to understand whether we're alone in the universe.
And they're not stopping there.
No.
Mangalyaan 2 is already in the planning stages.
Oh, really?
Promising a more sophisticated orbiter to further unravel the mysteries of the red planet.
The moon Mars, it seems like no celestial body is off limits for ISR.
That's right.
Your research even mentions a mission to Venus.
Yes. The Venus Orbiter mission, or Chandrayaan, is on the horizon.
Wow.
Venus is a fascinating and enigmatic planet, often referred to as Earth's evil twin because of its scorching temperatures and toxic atmosphere.
So what is ISRO hoping to learn by studying this inhospitable world?
Well, they're interested in understanding the dynamics of Venus's thick atmosphere, its volcanic activity, and its interaction with the solar wind. There's even a possibility of collaboration with France and Russia on a special instrument for studying the Venusian atmosphere.
So even as they venture further into the solar system, they're maintaining a spirit of international collaboration.
It's a win-win situation. Sharing expertise and resources allows space agencies to achieve more together.
Right.
And ISRO's growing reputation as a reliable and cost-effective partner makes them an attractive collaborator.
Okay, we've covered a lot of ground here. From ISRO's humble beginnings to their ambitious planetary explorations.
It's been quite a journey.
But what really stands out to me is their commitment to using space technology to improve life here on Earth.
That's really at the heart of their mission.
They're connecting people, empowering farmers, providing access to healthcare, and even helping us understand our place in the universe. What a legacy.
It's a story of human ingenuity, perseverance, and a vision that extends beyond national borders.
Yeah.
They've shown the world that space exploration is not just for the wealthy nations.
Right.
It's an endeavor that can benefit all of humanity.
And as ISRO continues to reach for the stars, they carry with them the hopes and dreams of a nation inspiring future generations to pursue their own scientific passions.
So as we conclude this deep dive, we invite you to reflect on what you've learned and to consider the questions ISR's journey raises. What role do you see space exploration playing in the future? How can we ensure that its benefits are shared by all?
These are important questions for all of us to consider.
They are.
And we encourage you to continue exploring the fascinating world of ISRO and the ever-evolving landscape of space exploration.
Keep looking up.
Keep looking up.